So far we've made two changes to our competition robot. We've switched from a slider climber system to shortened Andy Mark climber in a boxes. Then we've also switched to a lower pivoted shooter, which again allows us to clear, and it allows us to shoot from a further distance and makes our handoff a little more seamless. That's all the changes for our robot so far. We'll see you at competition.
While Mechanical was diligently building the robot itself, the rest of the programming team and I were implementing the necessary software controls to make the robot functional. The three main areas of the robot this year for us, programming-wise, were vision, autonomous, and subsystems. So we first prioritize preparing all of the code for the subsystems themselves, like the intake, the launcher, and the climbers, and we tested them with our prototype design. Currently, we are working on autonomous, which will allow our robot to participate and earn points in the 15-second autonomous period at the beginning of every FRC match. And in parallel, I've been working on our vision. Our vision runs on a Raspberry Pi 4 coprocessor and is at the moment able to detect and align with all the April tags on the field, and also detect and align with rings with YOLO V8 based machine learning. No, okay. Cut out the machine learning part out. I'm gonna rephrase that.
Okay.
So at the moment, our vision is able to detect and align with April tags across the field to allow for more precise and accurate shots and alignments, both during teleop and autonomous. And our ring detection, based on the YOLO V8 algorithm, is also able to assist us in that purpose.
Okay. I felt like that was...
So this is the FTC Mini Swerve Bot. It is for our 2024 off season. It is, of course, a mini swerve robot, so it uses these swerve modules right here, right? And I'm going to show you how they work, of course. So from the bottom here, we have servos here. These servos are attached to relative encoders. They're a little bit finicky right now, but we're working out some kinks in them. And these servos are spinning these larger swerve modules. These swerve modules are powered by the drive motors up top. They have a 15-to-1 gear ratio, and those give more than enough power for what we're doing. The belt here is what spins the motors itself, like so. And then this is able to provide power to the wheel down here. We, of course, have clear Lexan plates for protection, keeps it safe, and it overall works, for the most part, rather well. Programming aside, it's reliable. So, at the heart of it all, of course, I'll show you this in a little bit. We have all the circuit boards and whatnot. We got a control hub, an expansion hub. We're going to be using most of the ports on these. And we have, of course, plenty of future plans that I'll go over right now, actually. So you may have noticed this weird hinge-looking thing up top, this weird platform. Probably wondering what that's for. So we have future plans to create a modular platform, if you will, where in the current, our current state, we're going to add a ping pong ball launcher onto it, but we can add anything else we'd like to. It'll interlock onto a top gear right here with 4 different pegs, and that allows it to spin both, of course, clockwise and counterclockwise while it is on a swerve bot. Using this, you get maximum modes of articulation, plenty of different movement, and, of course, future-proofing projects. If you ever do anything in the future with this thing, it's able to adapt and use what we're using it for. Anything else to go over? So, in terms of what we have planned for the future, we want to use this little hinge system right here, of course, to create a more modular design, one that has not been seen in FTC before. So, using a larger gear attached up right here, right next to a smaller gear for maximum torque, we're going to have 4 pegs within this larger gear that you could then attach different platforms onto. Now, we currently are planning on making a ping pong ball launcher that will attach within these 4 pegs. And in the future, we might even create either a crane or whatever else we need it for. Now, with this system, we get maximum torque from the core hex motor, giving us plenty of availability and reliability whenever we're making the modules themselves. And we're also able to create more modules in the future to better future-proof this robot. Now, we do have other plans, of course, in the future for smaller projects with this thing, but for the most part, we're definitely happy with what it's looking like right now. It's mostly reliable, code is definitely going well, and as far as assembly goes, it couldn't have been better.
So this is our candy launcher robot that we've been working on this year. So the purpose of this is to shoot candy. And the way this robot works is you insert the candy in this box here, and it falls down into this platform launcher plate. And what happens is these pushers push the candy like this with the use of servo motors, and they push the candy into these entrapment stars, which compress the candy into the compressor and then shoot out straight at a 30-degree angle. And the candy launcher robot can also move in all directions with controls.
All right, so for the programming, we decided to add 2 different power settings for both the motors to make sure that we can change the trajectory of the candy flying during a parade or something. Now, our plans for the future is to make sure the robot that shoots consistently, since there is some issues with the intake and the netting, and decorate it to make it appealing to the children. The decorations will make it look like Halloween and potentially a witch with a black cat on it. That's it.
So this is the KitBot, a project that I've been working on for the better part of around a month. So the KitBot is really a simple project. It is built with a tank drivetrain that is powered by 4 sim motors, which are a bit more of a simpler motors than the Neos, but they get the job done. Next, then we have the superstructure. The superstructure is basically what takes in and fires our rings. It takes it in with these 2. It takes it in with these 2 flywheels. There was a part here with a plate, but that has since broken off. It was meant to guide the ring into the amp. It's powered by this Neo here and powered by using several different chains. Basically, it was more of a simple project. We had a certain instruction list that we had to follow, but me and my team were able to work on and get this the moving plate together so it can do an amp shot. Before it could only do a speaker, but now after into this project, all we really have left is doing the autonomous code and getting the PIDs done, which will be Vasil's job.
So our very first competition in Belton, Texas is coming up very shortly, next week in fact. And obviously, as a rookie team, we are very excited but nervous at the same time. My main personal worry is the lack of experience in actual FRC events we have, but we are determined as a team to perform to the best of our ability despite any obstacles we may encounter along the way. If you are interested in sponsoring us, you can contact the TWHS Robotics Booster Club or our head coach, Ms. Hamill. The contact info is listed in the sponsorships section of the TWHS Robotics website. The URL is www.twhsrobotics.org.
To everybody who sponsors us, thank you for giving us the funding to do what we do. This wouldn't be possible without you. We can't wait to see what's in store for us for the rest of the season.